The aim is to transmit the low frequencies. At the same time, we should have small size antenna. So how do we tackle this problem? The solution to this problem is we have to convert this low frequency range of the signal to some high frequency range and transmit that high frequency signal, because the frequency of the signal which is transmitted now is large. I can reduce the size of the antenna. On the receiver side, we will receive this high frequency signal. So again, receiver can also use small size antenna. And from this received high frequency signal, we will extract the original low frequency signal, which will be from 20 Hz to 20 kHz. And we will then use that signal on the receiver side to convert it back into sound signal. So very briefly, the whole problem can be solved by converting the low frequency range to high frequency range, transmit the high frequency signal, on the receiver side receive the high frequency signal, and extract the original signal of low frequency out of it. So this is something we will achieve through the process of modulation. Now see, this problem itself is very huge problem, and there is no need to discuss any more problems. This problem itself requires a solution in the form of modulation process, as we just now said. But let us also discuss few more problems which are involved in the setup of this communication system, and modulation will serve a common solution to all the problems. Let's talk about the second problem now. The second problem we will be discussing with the help of this particular diagram, in which what I've done is I've added one more transmitter. So we have the same radio communication system, but this time we have got two transmitters and we have got one receiver. Now because it's a radio communication system, once again both the transmitters will be transmitting signals which will consist of frequencies from 20 Hz to 20 kHz, which are nothing but the audio frequencies. Let me recall that this signal is called information signal. It will also be written as AF in many cases. So when I say AF, it stands for audio frequencies. The signal is also called information signal. Let us try to understand what is the problem involved in this second setup. Now it is very obvious that in any practical system there will be multiple transmitters. For example, we have multiple radio stations. At any given point of time, my receiver is only connected to one radio station. Now, how can I connect receiver to one radio station? Every receiver has a bandpass filter on its input side. Every bandpass filter has something called as passband. The filter allows only the frequencies which fall in the passband to enter into the circuit. So receiver will receive only those frequencies which fall into the passband of the bandpass filter, which is there on the input of the receiver. This is called tuning of the receiver. So it is very obvious that if I want to listen to a specific radio station, I will tune the receiver to the frequencies which are transmitted from that radio station. Now in this case, because it's a radio communication system, both the transmitters, transmitter 1 and transmitter 2, will transmit the same frequency range from 20 Hz to 20 kHz. So now let us say that my receiver wants to receive signal coming from the first transmitter only, and it does not wish to receive signal coming from the second transmitter. In this case, receiver will tune its bandpass filter to 20 Hz to 20 kHz, because that's the range in which the first transmitter is transmitting its signal. But what will happen is receiver will also end up receiving signal coming from the second transmitter, because second transmitter is also transmitting signal in the same frequency range, and hence what receiver will receive is the mixture of the signal. This problem is called mixing of signals, which takes place on the receiver side. Let's quickly summarize all the points. Why does the mixing of signals take place? Because both the transmitters in this setup transmit the same frequency range, 20 Hz to 20 kHz. If the receiver wants to receive signal from transmitter 1, it will tune its bandpass filter to the range 20 Hz to 20 kHz, but it will also end up receiving signal from the second transmitter. And once the mixing of signals has taken place, there is no way in which these two signals can be separated out.